We're going to be drawing our default map sprites. So yesterday we've got the ability to go from level 1 to level 2. We can go over here back to wherever we want to go. At the moment we can go down to 3, but if we try to index over here we crash because we've only got these top 1, 1, 1, 1, 2, and then 2, 1 quadrants. So today we're going to be populating those things so that we can potentially go in any of the 25 map quads that we've got. So what that kind of looks like is this. We've got a map at 1, 1 populated with all these sprites. Map 1, 2, map 2, 1. So what we want to do is we want to initialize all of these maps with a default sprite. And once they have a default sprite, we'd be able to render them as is with a default. And then as we build out the levels, we can overwrite the correct level design into them. So we're going to be tackling that today. It shouldn't be hard. It shouldn't be hard. We take a look at our notes. We've got populate all maps in our global map, and we've got maybe rendering our player in the scene class instead of the play state. We might mess around with that and see, because ultimately we want other entities in our game to be able to walk and traverse the map so that they can have a daily schedule, and throughout the time of day they can kind of have a specific path that you have to kind of track them down at, or in order to be able to talk to them or interact with them. That's kind of what I want, kind of like a Stardew Valley type of deal. So I think right now we've got, if we take a look, we've got this is okay. If we take a look right here into our map declarations, actually in our constants where we define those things, we've got an index number for each sprite. So right now we're able to render those billiard balls. Anytime we put in a first, that's a 1 billiard ball, 2, and this is because we split them up into our quads the appropriate way. But we want to do we want to add a sprite that's not part of our billiard balls. We want to do a repeating sprite that is our sand or whatever. We just need to give it a default sprite. We can make it the grass sprite if we wanted to. Let's take a look if we've got any of our old rendering for our level. I don't see us have that. We're only doing it based on the quad of our main sprite sheet. So if we take a look at where we give us that, we give us a couple drawables. We've got dirt, sand, and grass, and tall grass, but we need to put that into our ultimate sprite sheet. So we don't have that at the moment, and we can't just index into the quad at that tall grass. So what can we do to get that in there? We've got, see, for our tiles right now, for every one of our global map grid, every tile within each of those grids are being rendered by a tile ID that is getting set by these tiles, and those tiles are being set by the ID that we assign into it. So since we don't have a corresponding quad index for anything other than billiard balls right now, we'd have to overwrite our billiard balls if we want this feature added fairly easily. Or what we can do is, because we want to still be able to render our billiard balls if we want. Let me see, maybe we can make like a temporary 9x9 quad that isn't our billiard balls, because the billiard balls is useful for debugging so that we know, hey, that should be a 1, that should be a 2, that should be a 3. So like, it's useful to have that. So if we overwrite them with sand, it won't help us that much. So maybe instead of, see, look at this tile sheet is the atlas that we're drawing all of our things at. So what if we, I don't know where we declared this, because tile sheet isn't actually declared here in our map class. It might be in our play state. It looks like it is declared in our play state here. So if we give ourselves another tile sheet of 9x9 of our actual other sprites, then in order to render them, we would have to change this. And what we can do is, like, for now, since we're not going to be hard coding in all the final sprites for every single map just yet, we just want default values. So we want, what's up, aka Bob, how's it going? So I think what we can do is we can go ahead and render our default sprite. So we can go ahead and make a new sprite sheet, put our sand on there, default to rendering all the quads. I mean, not quads, we would just want to render the actual tile sheet at this same exact location as our current one, but we do all the defaults first. Like, we would render the default tiles first, and then this would be actually populated with the tiles that we want and that we explicitly set here in our map declarations. It's just that for 25 squares, we don't know exactly where all the tiles are going right now, so we just want a way to just put placeholders in there so it doesn't crash and we can actually walk and explore the map. Because if we walk around and we hold H, we can see that we're in map 1-1. We go over here to map 1-2, and then we'll crash. We go down, but we can go down here to 2-1. So we want to be able to give ourselves all 5 of our map so that we can just explore there and then ultimately render the correct levels there. So let's go ahead and we'll hop into Sprite here. And what we'll do is we'll just overwrite a couple of our tile. Oh gosh. Here we go. So what we want to do is open our 9-ball, which is here in our source picks. We've got our 9 circles. So what we want to do is we want to take the same idea, but we just want to put our other tiles on here. So what we can do is we could go ahead and open our sand, and I like the sand instead of dirt. We spent a little bit of time on this because this is actually like a smooth loop. So once we populate this with sand, it's like we've gone too far in the desert that we haven't put in the correct tiles yet. So what we can do for now is we'll just give ourselves a sand here, and we can, while we're at it in Sprite, we'll also add our tall grass and our grass and our dirt. So we'll add grass here on the second quad, and then we'll give ourselves dirt on the next one. And this is our dirt. Okay. So we've got sand, grass, dirt, and then the last one we've got is our tall grass. So this is just the only sprites we've made so far. So we'll put it here so that we can render a whole map with them if we wanted to. Cool. So what we'll do is we'll export this as a PNG, and we'll just save this as textures.png, I guess. Doesn't really matter. We'll what? we'll we'll go into our play state here, and we'll go ahead and import the drawable. And here. So what we'll do is we'll just call it texture because we named it texture. So we'll call it texture love.graphics .new image, and then we will import it from our path here at source pics, and then texture.png. We'll hope it exported. We didn't check that it exported. I'm gonna assume it did export. So now we've got a texture that we can render things. So now what we want to do is go into our map class. Now, right here, we're rendering all the tile sheet at the correct quads, but what we want to do is, and if we take a look, like we're giving our map the amount of tile IDs. Hold on a sec. Let me think this through. So when we instantiate a map, we have to pass in a row and column. And then that row and columns, for every index, all 80 of those indexes, they're being assigned into the ID. So I guess in our map declarations here, the constants we give here are overriding that map ID. Because yeah, we're rendering our tiles table. So this is every row of our tile. We're inserting an ID key and assigning it just a number. Okay, so yeah, this is just all 1 through 80. But I guess I'm trying to think of how that ID turns into the value that we pass in our map table. Okay, so it is just overriding it. So once we declare this, then our map 1 at index 1, so our count of 1 when this is on the first loop there, our ID is getting overwritten with this value of first that Lua treats as 1, which translates to an ID of 1, which means it's the first ID of the texture that we're drawing. Okay, so what we want to do is give ourselves, we want to render. And you know what? Why is it that, okay, so the first thing we actually want to do is go to our map declarations, and we want to declare a bunch of these tables. We want to loop through and give all of our map grids 80 tile IDs essentially, so that we don't crash, because what's happening is it's trying to render 80 tile IDs worth of map stuff whenever we go into a map square. Like let's say we go into the one that's crashing. It's crashing because it's going into map 2, 3. No, it would be, yeah, 2, 2. Map 2, 2. If we go right and then down, that would be 2, 2. And it crashes there because map 2, 2 doesn't have any ID values in order to draw any of the sprites. So I'm curious what it says. Oh no, did we really not export it? It's called textures with an S. Okay, so we'll go into our main, we'll go to our top, we'll go, we'll make sure that we get textures with an S here. We're not even putting it, I guess it's not in our main, it's in our play state. Okay, so it's textures with an S. We'll call it textures for clarity's sake here as well. Now I'm curious what it says when we crash when we go down to 2.2. It says you can't draw a quad expected in Gotnail. So it's trying to draw from quad, but it doesn't have a tile ID to draw it at because we didn't populate it. So we have to go into our map declarations. Now what we can do, we can leave these after, but as long as we populate every map 1 through 5 on both 2D arrays, we populate all those with dummy values for our tiles that actually map to something, then we shouldn't be able to crash. So we'll go ahead and try that. We'll say that we want to go do a nested for loop. So we'll say for x gets 1, comma, our overworld map height. We're going to do something a column amount of times. So we'll say for y gets 1 for an overworld map width amount of times. And what we want to do here is I think we want one more nested for loop because we have to go through 80 of these values, just like this. We have to go through 80 of these values and give them a corresponding value. So we can go into my constants. What I'm going to do is just call sand, save sand as 1 as well. That'll be our default. So we can go back into our map, and it's actually map declarations, and we can say we need another nested for loop, which is we can say for z gets 1, comma 80. We know it's 80 because of our map width times our map height, so we would just say that, and we can say that our map at our x and our y and we don't, I guess I'm a little confused on, we don't have to put tile ID here, but why not? Because when we're rendering our map, we assign a number to an ID count. No, okay, so what this is doing, it's like dereferencing this. So it goes map at our row. So let's say it's at 1-1. Map at 1-1 at count, which it'll start at 1 because that's where we initialize it. So that will be the first value in the table, which is the string first. It's actually a constant that represents a number, so it's actually technically a number of 1 gets assigned into the ID. So okay, so that's where we're assigning the ID value into each spot. So I guess what we need to do now is we need to populate our map row and column with a variable that turns into a number so that it can be assigned into the ID so that we can draw our quad at a certain ID. So what we'll do is we'll put in our sand and that'll translate to 1. So what we need to do, I think we can just say this at our index z. So it's literally like for each map and for each tile ID index, we're going to be assigning that index to be the sand constant. Now I don't know if I have to say what field it is. I don't think I do, because we assign it into a field in our map class. So I think we might be able to get away with this. I'm not feeling too hopeful though, but let's see. So yeah, we're going to our map row column, and then at the index, now there's going to be 80 of these, because every map has a set of 80 tiles to draw, and we're setting every one of those 80 tiles to be equal to sand, which is actually a number of 1. And then if each of our maps have those values, we're overriding those values with these values for our first 3 levels, but then every other one should have sand, because what we do here is for every map height and width, we go and we insert a table, and we do this. Let me think about this, because I would think we have to, how we draw the tiles is we give ourselves an empty tiles table at every height. Then we insert into that tile table a value of the map and row and count. So this is for every map width. Okay, so yeah, this is ultimately going to run 80 times and set the ID of sand to every single column. And then what we need to do is we need to render our maps with the correct quad, because right now we're only rendering our tile sheet, which is our billiard balls. But we need to render our defaults values first. So what we can do is say for map height, do something a column amount of times. And what we want to do is we want to do the same kind of deal where we say, okay, our tile is going to get equal to that tiles table that we inserted those IDs into. So that we can have a nice clean draw function, which is going to look like this. It's just going to be love.graphics.draw, and we're going to draw not at our tile sheet, but at our textures atlas, at our quads, at the index of tile ID. Now this tile ID we're giving is the tile object here that we're saving for every one of our tile tables. I think that's right. And then we want to draw it at an X of ultimately whatever tile size we're at. So we would say like X times tile size, but since there was 1 indexed, we've got to subtract 1 before we multiply it. So the first tile is actually drawn at 1 instead of 16, which is our tile size. And then we need to render it according to our map offset if we're transitioning. So we give it the offset X, and then same thing for our Y. What do you guys think are the chances that we did this right? I feel like not very good, but we'll see about that. Okay, so what we're doing is, let's take a look. And you know, I think so giving this line of code here is hopefully the same as populating every one of these tables manually, just with all sand. So instead of doing 25 tables where we insert all these values, what we're trying to do is insert only the value sand for all 5x5 maps. So hopefully that works. And then we render, first of all, we render all the sand tiles everywhere, and then we go back and we render any tiles that we actually manually assigned through our tile sheet. Now, I don't know if there's a mistake in that. I don't know if that makes sense to do, but we'll see. Okay, so we are getting sand underneath, so we aren't overwriting it we do have the sand, and then we have dirt and grass as well. Oh, it's the corresponding, so every 1 is a sand, every 2 is a grass, every 4 is a tall grass, every 3 is a dirt. But I guess the question is, can we walk further over here? We can. If we take a look at this, we're at map 2 too, so we're not crashing anymore, and we do have all sand. So now we should be able to go all the way down to 5-5. That's how big our map is, and once we hit 5 here on the row here, we should not be able to go down any further. We are able to go down. Our event listener should have prevented us from doing that. Let's see if we've got all the tiles over here. So yeah, we're rendering both tiles instead of one or the other, which makes sense. Okay, see, look, like that. We don't crash when we go this way, or crash when we go up, but we do crash when we go down from 5-5. Okay. Well, this is cool. We've got 25 grids to have a game at the moment. And we still can't go right, but when we go down, we crash. Okay, so we got to fix that. Let's take a look at... I think it's in our... It's right here. If down... No. I think it's in our event dispatch. I think that's what we were just looking at, and that wasn't it. No, it's not this. I think it might be in our actual on event. Let's see, event.on. Okay, yeah, so if our... So it's crashing on the down transition, and it's crashing if our current map... So like we should only begin shifting if our current map does not equal... Oh, this is what it's not the current map, it's the current map row. If our current map row does not equal 5, then we can go ahead and shift. So that should fix us crashing going down from 5, but we'll see. This is cool. We've got our little tile sets now. So we're in map 5-1. We shouldn't be able to go left, and we don't crash, so that's good. And we shouldn't be able to go down. Let's see. Yes, now we don't go down. So now we have 25 grids of tiles, and they're being defaulted to be sand. Now I don't know of a way to say only draw, don't draw the billiard balls if we didn't manually assign them. Because I want all these to be just sand, and then if we actually input a level manually, it would overwrite to be whatever the billiard balls are at the moment, I guess. I guess it doesn't really matter, but that's pretty cool. Cool. And it's got like a memory, so all of this stuff will stay, and all the logic. Every time we go to 1-2, it should be that frame. Every time we go to 2-2, should be this one. So maybe what we do is what? Maybe I want just sand on the other maps. I don't want these billiard balls rendering. So let's see if we can figure that out. We might need to just... Let's see. So if we go take a look at our map rendering, we render our textures first, which is why we're getting all the dirt behind the 3 billiard balls and all the sand behind the 1s. Then we render the actual billiard balls. So is there a way where we only render this if we don't have a ID already assigned to it? But we overwrite our IDs here in our map declarations, so that doesn't make a lot of sense. I guess we can manually say that this we render. Maybe we can start rendering this at let me think. I guess it doesn't really matter. It doesn't really matter for rendering that stuff, but I'd like a way to kind of only render the sand. You know what? Yeah, because if we change one billiard ball to sand, I mean, let's just do that. Let's just change our first to sand here in our map declarations. And then, because we don't need that feature in the game, we just need, we just want it for kind of, for cosmetic purposes while we're testing this. So we can just say substitute our first with sand. And then now, actually, yeah, because we're still rendering our textures. And our sand is actually the same value as 1, so that doesn't do anything different. Okay, well, I guess I don't know what to exactly do with that. I don't want to get so messy and add another kind of field to our map table because we won't need it. So we'll keep it as is for now. What we could do is just change our billiard ball quad to be the textures quad. So now we've got sand, dirt, grass, tall grass. So anything that's not one of those first 4 will be a billiard ball, but everything else will just be the texture. So yeah. So we've got sand. We've got a lot of sand. So anything that's a 3 is grass, 4 is tall grass and dirt, and then see, this is the sand that I wanted to see. I wanted to see these transitions without the billiard ball. So it's like it's nice that it's like a perfect loop of sand there. So I still want the billiard balls though, because that's helpful. That's helpful to me. I think what I want to do is export our textures again, but just only have sand, so that every sand we know is 1, and then everything else is still just a number. So let's go ahead and do that real quick. And then, so probably next episode, we'll start making a big tile sheet of all the stuff we need. Because right now we've only got four basic tiles, but we need all the edge grass, all the pavement or paved stone, all that stuff. So what I'll do is just undo, and we'll just save this as textures. So we'll export this as textures, and then it'll overwrite our current one in there, so we should just be able to run it again, and every 1 is sand, and then every other number is going to be the billiard ball. So 1 is a lot of sand because we made level 1 a lot of 1s, so that's why it's a lot of sand. So that's pretty cool. So now we don't crash by just walking in our game. We've got 25 squares to explore in. So I guess what's next is, ultimately we'll have to decide if 25 is enough. I feel like we want a world bigger than 25 squares. Because in the game, we want the present day stuff, which is in the Waystone Inn. That's probably going to be 8 grids, maybe 6. And then when we talk to the chronicler, we can go back to the university, and that's going to be a lot because that's going to have all the different classrooms and the all the mini games for like the crafting and magic stuff. And then so that's probably at least, yeah, that's probably at least like 15. So maybe we want like a 10 by 10 map. And what's cool is, I guess what we can do is here in our constants, nope, in our map declarations, we can say, okay, give us an overworld map of actually 10 instead of 5. And then now we'll get an empty map at all of those, and then we populate all of those with the default of sand. So now we should, and we'll have those first 3 maps as whatever these are, but hopefully we should have a 10 by 10 map now. So let's see if that's working. We should have 10 by 10. Let's go down, let's go down. Yes, cool. Okay. Now there was a feature too that one of our viewers recommended, like if there's like a swamp type of sprite, to give us like a kind of sprint button so that we can kind of go a little faster through the swamp. So we do have our grid of 10 by 10. So we quadrupled our game size from 25 squares to 100. So now that should be plenty of tiles for us to do anything we want. I really like the sand. The sand looks pretty cool. It's cool that it looks like a perfect loop and it's only the 16 pixels. So I like that. Cool. So we've got a 10 by 10. We'll have to decide how many sprites in our sprite sheet we're going to ultimately need and then design them. And then we can start manually building out our levels with the corresponding sprite sheets. And then we'll go, I do want to see what happens. We did this, we got populated all our maps in our global map table. So we've got that. Now, I do want to see if we can render our player in the scene class instead of the play state. So we'll see if we take a look in our play state here, or if we go to our play state, we see that we're updating our character here, which makes sense. And then we're rendering him here as well. So let's just see. Let's see if we render our character in our scene state instead. See if that changes anything with the scrolling. Let's see. We go to our scene, we go to our render, and we're going to render the scene, and then the current map, then the next map, and then let's go ahead and render our character. Let's see if that screws up the shifting here. Yeah. So we want to, yeah. So this is because we're translating the screen. So Kavoth kind of translates with the screen that's moving off. I don't know. I don't think we need to do this. I thought that we should maybe do that. We should probably move the character into the scene state, because once we have other entities and other characters, we're going to have to put their rendering somewhere and their update somewhere, and I didn't think it made sense to put them in the play state. I thought the entities should be kind of relative to the scene, but they'll be able to be walking around, so I don't know. Now I am kind of curious if we're rendering all the sprites at all time. I'm not exactly sure if we are, because if we look at our map render, we don't say only render current map, we say to draw all of these things next to one another. So I guess I'm curious. Let me see something. If we go into our constants here and we give ourselves, let's say that we give ourselves the tiny window. Okay, no, this I can't. I don't know how to do this with push because they're rendering it for us. They're handling the size of what to render. So I'm curious if we are rendering all the tiles at the same time. Like all 100 tiles are being rendered, we just can't see them. I don't know how to check that, but I think that's the case. No, it isn't. It isn't. Because we only go in our map, we only render, actually, our map when. So if we render map, it's going to render every map width and map height, and what map width and map height is just the 8x10, I believe. Map width and map height, where's that? Yeah, 10 and 8. Okay, so yeah, any map, we're only ever rendering those 10 pixels, and the only exception is in our scene transition. So we're rendering a current map, and if we're in a scene transition, we're rendering a next map. So we're potentially rendering two maps at the same time every transition, but we stop rendering it as soon as it's done transitioning. So we're only ever rendering a very tiny amount of things to the screen. So cool. Okay, so that was a good little piece to get done. We can plan out what is next. I still feel like we should do this differently. We're gonna go through eventually, probably sometime soon, and do an update where we're turning our character into an entity and having the entity have an animation class, and do more of a data-driven design for the game, because ultimately I do want a bunch of different entities and characters. So we're going to change our animation class to be inheritable by all our entities, so we don't have to do what we did with our player class, which is define our frame advance, define which frame we should be on, what our default stuff is. So we're probably going to refactor a lot of that into a animation class for all of our entities to have, and then we can add other characters. And then I want, one thing I am kind of stumped on is, how do we have other characters in our game have a set schedule for where to walk, even if their screen is not being rendered at the moment, right? So like we can populate our map object with a bunch of entities, and we can have those entities have a current map location, and that current map location is a grid of the map it's currently on, as well as an X and Y of that map. And then we can just, I guess, program in the DX and DY, or the whatever AI we want for it in that. And would that be in the map class, or? That's one thing I'm not sure how to do, because I ultimately want, when we go to the university in the game, we're going to have like a time schedule for when our class starts, and then we're going to have other students that walk around and other teachers that have set paths. So like during the day, you can only find Eladin at certain times, at a certain path. He'll walk there and you can talk to him and stop him. But we need to kind of manually assign those different pathways, and keep track of them even when they're not on screen. So like, that's one thing that I'm really interested in kind of doing. And I'm not so sure how we do it, but I know the best move for us is going to be sooner than later turning into a data-driven design for our entities, so that we can easily keep track of that. And you know what? Let's take a look. If we go, we can take a look at the repo for CS50 Zelda real quick, and we can see how they do that before we call it a day here. And we can see, so their game first of all looks like this. This helped us get the scene transitioning. Now this is way slow because I was looking at how the transition was, so we can speed that up again. But see, they've got this entity, right? So this is a class called entity, and it's got a direction, it's got an animation instantiation, it's got its own XY with height, walk speed, health, dead status, and then there's this function called create animations that we say, hey, you have to give it a texture for which ones, which frames for which quads to be, and then the interval for how fast they need to change. And then, okay, that's a lot. That's a lot. Let's see, I want to go back to the dungeon. And if we go to where they tween their camera, I think it might be in the room then. No. Tween, here we go. So this is more like 2 seconds or 1 second, and that'll be faster now to transition the screens. Yeah, so probably 1 second, but we do want to do something like this because their game, look at all the entities they've got. Now, theirs is fundamentally different than ours because ours is gonna have entities with memory. So like they generate a random amount of entities as you walk into the room. As you transition, the next room gets populated with a bunch of random entities. But we want a set amount of entities, and they have their own AI outside of us, and they walk around the screen, and we keep track of their locations so that if we walk into the grid at the same time they're potentially in that grid, they'll render in that grid, but they don't render there if they're not there. So that's going to be an interesting feature in our game that we'll have to figure out how to implement. And soon we'll be adding hearts to our character as well. I want to take a look at their entity def. So they have let's just type in entity here. And they've got an entity def feature. What is it? See, and then they've got, so they're handling all their different walking animations through, you know, they're just doing it once in the animation class for entities, and then it gets set automatically. So that's what we're going to want to do. Entity defs here. See? So we want to do something like this. This is the data-driven design I'm talking about. Like, it's nice to just be able to just be really clean like this and say, hey, we have a player. We know it's the texture of our character walking. We know it's these frames for our quad. We know it's this speed for the transition, for the animation. And we can kind of map it out this cleanly, because we're going to have a bunch of different animations. If we're holding a torch, you know, our animation is not going to be our normal character walk. So we're going to ultimately want to change it to be more similar to something like this. So I don't know when we'll do that. We'll probably do that soon, because that's going to be a big part of the game. And on this channel, I'm trying to give us a big bang for our buck. Like, I wanted to get our map working so that, I mean, at the moment, now we have, 10 by 10 maps. So we have 100 grids to walk in. So I knew we wanted to get our character looking decent and getting our walking for our maps going, because that gives us so much game to play with. So I think entities is next, so that we can add, a swamp full of bats or whatever we want. And then we can start populating our world with entities. So the next big steps are designing our tile sprite sheet for designing the worlds, and then populating entities and all of the animation that goes with those. And then ultimately we're going to have a dialogue system where we talk to people, save our game. We're going to be implementing that, save. When you save, it's going to save your inventory. It's going to save your... Dude, I haven't played Candy Crush since high school, I think. But if you're in the 7,000 levels, you don't need my help. I need yours. Okay. So yeah, we're doing good. I like this approach of, like, in the next episodes we kind of tackle what's going to give us the biggest bang for our hour or two of developing. So next on the list is our sprite sheet designing, and then we'll work on entities, and then ultimately inventory system. So, like, let's go ahead and add a couple of these as notes, and we'll say inventory system, wherein you can make money and pick up things. We want the dynamic lighting system. That's going to be cool for the time of day. We'll call it time tracking, day tracking, day of the week tracking. There's so much stuff we can add here. Maybe, this shouldn't be in next episode. This is just in our to-do. Okay. And then next episode will probably be sprite sheet additions. So we want, edge of grass, we want pavement, we want trees, we want I don't know, a whole bunch of stuff. Okay. I still don't know how to do this. We want to do like a research tab for me to look into off stream, so that I can kind of bring to you what I've learned. And what we want to do is entity tracking for grids outside of our view. Yep. Okay. So we've got a couple of things to go. We've got 100 levels on our game as of today. You can't do anything in them, but you can walk there and see the sand, so that's cool. Yeah. So tomorrow will probably be a chill stream of just making some new sprites. But thanks for watching, y'all. We're trying to get to 20 followers, so if you're watching and like the show, you can give me a follow and stay on track with the development process. We're gonna go ahead and do our git commit here. Let's take a look at our git diff first, and all we do is render our texture tiles instead, and we populate all of our maps with a default of sand. And that's all we really did today, but the effect was nice. So we can say added default sand to our levels. And map is now 10, 10 grid. Cool. So we'll call it a day. Thanks for watching, y'all. I will see you guys tomorrow, and we'll do some sprite sheet animations. So thanks for watching.